Hey, welcome back. I hope you're all well. Thanks for joining the channel again, and good to see you. Today on my bench I have a pair of NADs. This was brought to me by one of my new clients, Kelly. Kelly previously seen one of my videos, and he contacted me. He said, hey, I got a couple of NAD amps. Are they worth fixing? And I says, yeah, well, NADs are always worth fixing. People are always looking for these. So he brought me these. He said the story behind these is he bought them at an online government auction site, and they were part of a server, kind of like a server cabinet, but it had audio-visual equipment in it, and these were on the bottom. I guess these were the power amplifiers for the audio part of it, and it came as a part of a group of other items, and he says they don't work. Or at least I think he tried them out and they didn't work, and he wants them repaired. And I was looking at this, and yeah, it says on here boardroom 8B. So this was part of in a boardroom, and it probably my suspect is these were part of an audiovisual setup in a boardroom, and you know. Once they turn these on, they leave them on 24 hours a day for years and years to come. And anytime they use the boardroom, it's all powered up and ready to go. They don't bother shutting it down when they're not using it. So I have a feeling a lot of the internals are cooked on these just from sitting on and idle for so long a period of time. So he brought them to me. He wants them fixed up. I'll get them going for him. These 2 amps, I believe I looked and they were produced in the year 2000, so they're not that dated. They're dated, or you know, they're new enough that they have. Well, here, let me reposition the camera. I'll have a look at the controls. Okay, these are C350s. They're integrated stereo amplifier. Both identical. I haven't checked the serial numbers. Maybe they're cousins. This power switch, your chunk power switch, and a phone's output jack. It has a window for infrared remote control. It has the function buttons here, disc. I don't think that's phono. I think that is maybe video disc player. I don't think this has a phono stage in it. So that's why I mean it's dated, you know, year 2000. I think about that time manufacturers were done with phono stage. CD video auxiliary, so it's got lots of inputs for different gizmos. Tuner, and it's got 2 tape loops. Tape monitor 1, tape monitor 2. Basic bass and treble controls, and a tone defeat button, which is a nice feature. Balance. These knobs are all center detented. And then a volume control. And that's it. That's all there is. Let's have a look at the back. Alright, so on the back we have our NAD link in and out. That's for daisy chaining several units together. I'm assuming using the remote control to control a number of units. It's got disc, CD, video, auxiliary tuner inputs, and these are all gold plated. It's a nice touch. Tape 1, tape 2, and then we have 2 outputs for preamp. We got and a main channel amplifier in, and they're bridged right now with these bridging jumpers. Now, having 2 pre-outs is a nice feature. You can have different power amplifiers and set it up that way. 1 output for speakers, and it runs a minimum of 4 ohms. And it has a soft clipping feature, which most NADs have. And trigger out. I guess this is for your power amplifier, 12 volts at 100 milliamps. I guess when this goes high, turn your power amplifier on. And that's it. Courtesy outlet. Pretty sparse. Not highly optioned like you'd like to see them, but it's a good functioning setup. I think there's enough here to keep any home system going. One set of speakers kind of limited, but whatever. So since I have a pair of amplifiers, I was wondering what to do with this. I was wondering to make one video for the both of them, or I think what I might do is make 2 videos, one for each amplifier, depending on how badly it's damaged inside or what's wrong. I don't know. one amplifier here. Was it this one or the other one? I had, when I was moving these around, I was giving him a little bit of a shake, and there's some stuff rattling loose inside here. Kelly said he had the lid off and he looked inside. He saw what looked like leaking capacitors, but wasn't sure. So that's why he put the lid back on and brought them back to me. But I did hear something rattling around inside, like there's something loose or not connected. So I'm not going to plug these in yet until I have a look inside. But I think I'm going to take this one first, and we'll have a look and see what we can do with it. Okay, so here we go, the big reveal. Pull the lid off. Looks fairly clean. So I'd expect it to be clean after being in a non-smoking environment. And what do we have here? There was something rolling around. Oh, look at this. Okay. We've got a 1000 microfarad capacitor. And one leg is completely chewed off of it. I don't know if you can see that. But it looks like it was desoldered. Where did that come from? I'm not sure. I'll have to find out where this came from. I don't see any missing components here. These capacitors look like they're cooked. They're a different color blue. You see the difference? And the heat shrink is kind of shrunk a little bit more than what the factory is. But looks like it's just a bad case of capacitors. Okay, I found the source of the capacitor. It's here on the power supply board. And I can see the glue. Yeah, that capacitor fell off right here. There's a spot. I don't know, you can see that here. Move this up. There's a spot here on this board, this power supply board, and it's missing capacitor. So this is the one. Wow. Okay. Nice construction. I've got these big beefy power transistors, 4 of them, and a nice toroidal transformer. Holmgren. What's a Holmgren transformer? Custom manufactured for NAD. Is that a brand name, manufacturer, or is that a type? I'm not sure. You guys tell me. Okay, it's going to need a good cleaning. It's dirty, and we have some cooked capacitors here. Looks like we had a bad capacitor here, so let's tie into this. So it's got a removable bottom on part of the chassis, which is a big help. Main access to the main part of the PCB board. I'll just remove these screws, and we'll have a peek at the underside. I expect it maybe got a few cold solders. And somebody put Velcro on the bottom of the feet here. I don't know what that's all about. Pull these off. It just makes it stick to my bench. I don't know what the purpose of this was, just to keep it from walking across the room, I guess. So I take get rid of this. Okay, so here, have a look. Yeah, and you can see from the heat what areas are being cooked. So I'll have to go over this with a magnifying glass, make sure that we got no cracked solders on these areas, and we'll make sure it's good. Actually, the soldering looks not too bad, just at the first glance, so I think we're going to be okay. I think it's just going to be a case of this thing's going to need some new caps, and then it's going to be put back in service. Okay, just doing some spot checks on the capacitors, and I'm finding a lot of problems. A lot of these capacitors are cooked. You can see that they're cooked just from the color. All these capacitors started their life off as a blue capacitor, like this. And you can see some of them here are turned gray from the heat. And some of these have started to make the transition to gray. They started to get that dull blue color, and once the blue color washes out, it turns gray, like some of these ones here, and some of the smaller ones. But I'm just doing some spot checks here. This one here, for example, is a 47 at 25 volts, so it should be right at 1.2 ohms or less. So let's measure this one. And here it's coming back at 90. It's completely gone. Here's another one. It doesn't even register, so it's over 100 ohms. My meter only goes up to 100 ohms. This one here, another, it's over 100 ohms. This one back here, 60 ohms, and it should be 1.2 or less. So I'm getting a lot of high, super high ESR caps. Here's one that's 10, and that should be 10 microfarad at 50. Should be between 2 and 3 ohms, and it's coming back at 10. Yeah, there's a lot of bad caps in this. That one's 11. It's bad. What does this one say? 8.8. It's getting better, but not good enough. 4. So yeah, as I move away from the heat zone here, these capacitors on the outside edge are a lot better. They haven't been cooked as bad, but these ones in the middle here are definitely all shot. Same thing here. I was going through and checking some of these. Here's some caps. Try this one. It's over 100 ohms. See if I can find another one. That one's 2.8. It's not bad. Let me check these big ones here. I gotta get them from the other side. They are 220. What voltage are they? 220 at 50 volts. Okay, I'll spin this around. If I can locate these. Right. Here, okay. So 220 at 50 volts should be less than 200 milliohms. Let's check this one. And we got 6.9 ohms. This one here, 23 ohms. Those capacitors are completely shot. So yeah, it's no wonder it didn't work. So I'll get through. I'm not going to recap the entire amplifier. What I'm going to do is I'm going to recap the bad ones. A lot of these ones out here in the fringe areas, they are not bad. For example, I can test this one is your 10 at 50. For example, this one out here, it's 10 at 50 and it's out in the cold. So let's see what it says, 2.6. So that reads normal. That's normal. 3.2 is a little high. 4.5 is a little high. See, the closer I get to the heat zone, the worse they get. Now there, that one's good. That one's borderline. And that one's borderline. So yeah, I'm not going to recap the entire thing because there's caps out here in the fringe areas that haven't been affected by the heat, and I'll leave them alone. Just in the interest of saving my client a few pennies or a few dollars in costs, I'll just recap what's necessary. The capacitors that failed and the capacitors that are on the way out, they'll get checked. I still need to figure out how to get this little power supply board out. I'm pretty sure that cap is bad. It's all gray. There's another one in behind there. There's like a heat sink right here. And there's a couple of cooked ones in here too. So we'll get on that. Kind of a close-up here so you can see what's going on with this power amplifier. This is the driver transistors. Look how they stacked up these two transistors on top of each other and bolted them to the heatsink. I don't know if that's the right way to do it. I'm kind of giving NAD a thumbs down for that. Why did they do it that way? They could have just as easily mounted the bottom transistor on the other underside and flipped it around and bolted the two transistors back to back so they would have been sharing the heatsink. But this is kind of dodgy here. You're expecting the heat to flow from one transistor through the other to the heatsink. And yeah, that's kind of a thumbs down for me. I don't know. I thought NAD was better than that. Anyways, look at these capacitors, how they're cooked. See how they're turned gray? You see one here and this one? These are kind of, where is my... These ones are changing color. These ones are really getting in the firing line of the heat. And these are the worst ones in the middle. So this is the color it should be. And this is how they change from the heat over time. These littler ones, the smaller ones, they do the same thing. And then even up here, I don't know if you can see these ones. No, you can't. Even these ones up here are starting to go gray. They used to be blue, like some of the other ones. It used to be blue like that, to be honest, but they're getting cooked as well. So there's a lot of heat generated in this area. Yeah, it's too bad NAD is kind of... I don't think this is designed properly for the amount of heat it's got to dissipate. Got a lot of transistors standing off the board, which is fine, but we also got a lot of high current semiconductors here causing a lot of heat. And these heat sinks on these transistors are poorly thought out. Okay, so this is the first one I pulled out. This is a 100 microfarad at 63 volts, and it comes back at 26 microfarad and dropping as it cools off. 45 ohms ESR. For comparison, here's a brand new cap I'm putting in. This is what I'm going to put in. And it comes back at 99 and less than half an ohm ESR. So yeah, there's a big reason why this amp didn't work. Here's a gooder. This one is 25 volts, 47 microfarad. I don't know if you can see that. Probably can't. But it comes back at 40 nanofarads at 190 k ohms ESR. It's totally garbage. So to remove the power supply, this is all power supply here, you're going to have to remove the back panel. There's no way around it. It's all integrated. And once you get the back panel off, it's not too bad. There's maybe a dozen screws and it comes right off. Unplug all the connectors. They're all pretty much polarized, and you can't mess those up because they're only going to go back together one way. And then you're going to be, your power supply is going to be hanging by these wires, which is coming from your transformer. You can't really disconnect these. So what I want to get this board out, so I'm going to just remove this board, but it's soldered in place. So I'm going to do some desoldering here and remove one board from the other, if this thing will allow me. You can't really work on this board from above. I'll just take some of these out. You see, will this work? I don't think my tip is big enough. That should be desoldered enough. Just before I go too much farther, if you can see all this in one frame, let me move this down a bit. So before I go too much farther, we got a couple service bolt-ins for the C350. One of them, the problem is the standby transformer voltage is dropping, or a unit won't turn on from standby mode. And the cause is capacitors C511, 512, and 513 are shorting. And these three capacitors are ceramic discs. So the solution is change 511, 512, and 513 from 100 nanofarads, 100 volt ceramic disc to 100 nanofarad, 100 volt metallized polyester film. Now if we look here on this board, this power supply board, it's kind of difficult to see, but I'll point them out to you. These three capacitors here, C511, 512, and 513, these have been upgraded to metal film capacitors. So that change has been done at the factory. If you had ceramic discs in there, you want to pull them out and replace them with 100 nanofarad film capacitors, 100 volt minimum. Next service information bulletin is resistor R227 is underrated and it's overheating. So the solution is change from R227 from a 560 ohm half watt fusible resistor to a 560 ohm 2 watt fusible resistor. And again, if I look on my example, resistor 227 is down here, and I can see it's been replaced with a 2 watt version. So that one's been done at the factory as well. So that's out of the way. So now we got this apart. Let's take these 4 screws out and pull this board. I'm finding a lot of the capacitors I'm pulling out are just garbage. They've been cooked beyond use. And another thing I've noticed is this thing doesn't have much dust. So like from what the guy told me, he was sitting in a server cabinet or an AV cabinet, and it probably was starved for air circulation, and I didn't see much dust, so that kind of confirms that, you know, the board's probably been sitting inside something. So this should be loose now. Pull that, there we go. We can service this. Okay, here's our little power supply board removed. So it's a pretty simple circuit. I think it's got 3 supplies on here. To tell you the truth, there is a positive 12 volt regulator here, positive 5 volt regulator here, and then I think there's an unregulated 37 volt supply, which is these 2 cans. They're 220 microfarad at 50 volts, so it's plus minus 37 volts. Yeah, plus minus 37, and then there's a plus 5.6, and I think there is also a 12 volt supply. Maybe the 12 volt is just local for this little relay board. Yeah, so let's, here's our failed capacitor. You can see it. The one leg broke free, and the other leg pulled out. It looks like it broke free. There's a little bit of a cracked solder there, so let's clean this up. Clean up this one. Okay. So we can remove this garbage. And clean this up. Now, the owner of these amps told me he looked inside, he saw leaking capacitors. I think he was looking at this. This is the circuit glue for these big capacitors, and that's not leakage. This was leakage here, but it didn't stain the board, and it didn't go through. So we got lucky on that one. But this here is just circuit glue, and this stuff can get conductive when it turns dark brown like this. And there's actually transistor leads here that are saturated with it. So I'll clean this up have to clean this up because it might do flaky operation. It might switch on the amplifier at random, or it might shut it off at random. Who knows what those little transistors do. Okay, so I'm just going to clean this board up a bit. Let's get a little bit of alcohol. Clean up that area. See, that glue doesn't want to come off. Clean up the backside. Okay, so what came out of here was a 25 volt 1000. So I'm going to put back in a 25 volt 1000. And I don't think we have temperature problems on this board. I think all the temperature problems were on the main board. I don't see any scorching here going on. So we should be able to get by just fine with 85 degree C capacitors. Some people say, well, it has to be 105, has to be 105. Well, not in all cases. I think 105 C capacitors have their place. Of course they do, but not when there's no heat. Okay, so here's another capacitor. This is 1000 at 16. Let's remove this one. I suspect it. Actually, let's test it first before I take it out. That's a good idea. A novel idea, that is. So 1000 at 16 should be about 90 milliohms. And what do I got here? 80 milliohms. But let's pull it out and test it anyway, just to make sure it's working. And we got the right value. Come on. The ESR meter is great for spot checking and determining if you have a problem, but they don't tell you everything about the capacitor. So I'm just going to connect this up and see what it measures. What the hell is it reading? Is this right? Something's wrong with this thing. Here, I'm going to put my camera on my meter and show you what it's showing. Showing me maybe my meter's buggered up. Okay, let's connect it up here. Here we go. Let's connect it. That capacitor, I think, is shorted. Let's check for DC resistance. It's completely shorted, that capacitor. And that's not my probes. That's unusual. DC resistance of less than an ohm for sure. And it's just reading random numbers. Okay. So let's put a brand new cap in. I'll show you what a brand new cap will look like. (915 microfarad, 100 milliohms. It's pretty good. So yeah, it was a good thing I pulled that out because the ESR meter didn't capture that. The ESR meter only showed me one thing, and that was, yeah, it's a bad capacitor. Okay, let's get this orientated right. So if you have a NAD amplifier, or receiver for that matter, pretty much betting the capacitors in it are junk. All right, now we got 4 more. We got 2 little ones here. I think this one's cooked. It's 100 microfarad at 16 volts and another 100 microfarad at 16 volts here. So I'll take these 2 out. Let's check them first. We got our meter here. Where is this one? Right here. Okay. 100 microfarad, and it's measuring 46. That's no good. And this one here, 7.2. 100 microfarad at 16 volts should be about 0.7. This one's reading 0.72. No, 7.2. Sorry. Oh my. So it's 10 times what it should be. Okay, they're both coming out. Now you can see why I didn't even bother plugging it in and turning it on, because I think it would just be an exercise in futility. Okay. Microfarad at 16. Yeah, this measures 7 microfarad, not 100. And it's got a 95 ohm ESR, which is garbage. Next one. It's probably even worse. Here we go. And this one measures 2.1 microfarad and 350 ohms ESR. 2 bad capacitors. Okay. I'm going to put 25 volt caps in. Okay. Now that leads me to suspect these 2 big caps here might be bad too. They did ESR fine. 2200 at 50 volts should be somewhere around the 50 milliohm mark. So let's try these. And we got 30 milliohms. Milliohms. But I don't believe that. Let's pull them out. They're not leaking. So let's see what they test out as. Not bad. Got 2000 microfarad, 43 milliohms. They're down a little bit. Same with this one, 260 milliohms, or sorry, 2060 milliohms. Sorry, 2060 microfarads, 41 milliohms. So they're going to go back in. They're good. This one was no good. And then we're done with this. I'm going to clean this off, solder these two back in, then we can reinstall this board. All right, so I took out the two main filter caps to test them. They both tested out at 19,000 microfarads. They got some good weight to them. They're not maracas. So I'm just going to leave these in place. I think they're doing okay. They both tested equal value, equal ESR, down around 17 milliohms, I believe. And I think these are still good. They're going to go back in. We got the little power supply board already done up. I got it cleaned back here, except for one little solder ball I missed. There. And I'll check this over with a magnifying glass. I'm pretty sure I did it already, but I'll do it again. Anchored these caps down so they're not flopping around. That's a big thing when you put these bigger caps in. You have to anchor them. The glue that they used on these boards was a joke. The capacitors were glued down with something, but after time and all that heat, it just kind of evaporated into a little stain, and there was nothing there holding the caps at all. And yeah, so same thing with these big caps. The adhesive they used to glue them down just wasn't doing anything. I think they got ripped off on that batch. But I'm going to reassemble all this now and put it back together. I still have a little bit of recapping to do here on the main board. I did the power amplifier already, and I still have a few down here to do where it's been heat soaked. I can see some bad caps just from the darkness of them. So I'm going to do that next. Okay, I finished finally, and what I thought would just be a few spot changing of caps turned out to be pretty much everything here is garbage. Every cap I pulled out of this thing was bad, with the exception of a couple of the main filter caps, and these two main filter caps, they tested okay. Those are the only ones that tested okay. Everything else was garbage, so they all got changed out. So yeah, it's turned into pretty much a full recap, or a 95% one anyway. And the state of the capacitors of this thing was pretty sad too. I tried replacing where I could with 105 degree C capacitors, but I didn't have a full inventory of all 105C capacitors, so I had to put in a couple of 85s. But it sure beats the manufacturer putting all 85 degree caps in this thing and then having them fail within 20 years. Catastrophic failure on a lot of them. Like I said, pretty bad. So I still got a couple things to do. I want to clean the bottom of the board, and then I need to anchor a couple of these caps down with silicone so that they stand a chance of surviving. So I'll do that, and then we'll get on to some testing. All right, so we got two adjustments. One is the output offset voltage, and the other one's the idling current, which is pretty typical for an amplifier of this kind. So connect a voltmeter to left channel, and we'll turn it on, adjust VR102 to get a reading of 0 volts, plus minus 30 millivolts. And here's my meter hooked up. It's reading some kind of phantom voltage. Got my pot tweaker here. Let's turn this on. It's going to go pop. And we have no relay click, so we might have more troubleshooting on our hands here. We got no power light either. I did check these fuses, and they were all good. Let's see if I'm missing something here. There is only 4 fuses in this thing. Let me check some voltages on the secondaries. See if I got anything at all. I didn't hear the transformer. Usually you can hear the transformer when you power it up. Okay. Completely dead. Well, looks like we have nothing on the primary. Let me check for primary resistance. Yeah, we got nothing on the primary. So we either have a blown fuse somewhere, but I don't see where there is any fuses, or our transformer is open, which is not a good thing. Let me get in here and check the transformer primary. Okay, so we got a problem here somewhere in the primary circuit. Now I checked the power cord. I got continuity on both wires, so the power cord is ruled out. It's good. I did check this secondary, or this auxiliary transformer. This one's for the remote control. It keeps the microprocessor alive for that. And I did check the primary on this. He's brown and can't remember which one it is. Brown and black, or brown and red. And there is 300 some ohms on the primary of this. So this transformer is working. It's not open, but I still don't see any of that 300 ohms on the power cord. So I'm wondering if there's a fuse in here somewhere that I can't find or see. I know there's 4 fuses here. These are all on the secondary of the transformer, and these are for the different supplies. But I don't remember seeing a fuse when I had this board out, and I'm wondering if there's a problem somewhere on the printed circuit board, but I didn't see anything. I would have seen a burnt trace or something like that, and there was nothing like that. The only other thing is it could be a bad power switch, but I'm going to look at the schematic and see if there is a fuse on the primary. Alright, I think I found the problem, and it was fairly simple. It's a convoluted system they have here. The power comes in, and it goes to this power switch, and when you turn this on, the main transformer here is energized by this relay. This relay is controlled by this standby circuit. The reason I got nothing dead here is because this is the primary and it's center tapped. It got red and black, and the brown is your center tap lead. So if I go and I check red to center tap, I get 300. I was getting 300 ohms. What's going on here? Come on. Okay, there's 340 ohms from the one leg to the center tap. From the center tap to the other leg, I got absolutely nothing. It is open circuit. And I checked the schematic, and this black wire has a thermal fuse in line with it. So the thermal fuse inside here is open. So we're going to have to deal with this if we want to get this working again. So let's do that next. Alright, so let's open this up, see what we can do for it. I have a feeling we should be able to change a thermal fuse. It's pretty simple. I got thermal fuses here. And if not, I'll order one. I'm not going to let a simple thermal fuse stand in the way of a working amplifier. Come on. Is that soldered? I don't think so. Might be. Let's try this side. Okay, you can take this. Now we can get it. It was just stuck on there good. Okay. And pull off the bottom plate. Off the top. And our thermal fuse should be in here somewhere. Not seeing it. Might be on this side. Although they don't like to do primary side wiring on the secondary. Okay, so what do we got here? Two windings. It's pretty dried up. Everything's been baked. So there's two windings, one on the top, one on the bottom. The bottom one is your secondary, and they're separated by this piece of plastic here. There's a piece of plastic in this, and then the primary is on top here. Now, where did they bury the thermal fuse? That's the question. It's got to be here somewhere. I don't see it in there. The other option is get another transformer. I think this has two different windings. One's 14 volts, one's 8 volts AC. I don't know the current rating, but I'd have to find something that would be suitable. Gonna drop it right in and fix this. Okay. Still don't see anything. Could it be right here? Could be. There's a bump here, right there. That's where it is. Dig this thing out. Okay. I really buried it. I need to get. Just want to be careful not to cut any windings. Okay, I can see it See, there it is. There it is. It's a little rectangular box. I was expecting maybe a cylinder. But we can read see the wires. There's one wire there. The other wire there. Okay. Let's snip that biatch out of there. Okay. Can't read it. It's all covered in tape gum. Okay, here we go. Pretty tiny, I can't see that. Alright, what do we got here? (117°C, 250 volts, 1 amp. Okay, so I'm going to probably have to order this. I don't think I have a 117C. Probably not in this form factor. But if I could get a fuse, I could solder it back to those two wires. Hope I didn't wreck that other wire. Nope, that is the connection there. Okay. I advise not bridging those two wires together and then putting it back in service, because you're actually eliminating all your protection. And get another thermal fuse. We'll put it in there. We'll wrap it up so it's snug as a bug, and then we'll put it back together. All right. So bad news. I can't get 117°C thermal fuse in the size I want. I can get them in much larger, but they won't fit in the case here. So I had one of two options. I could go to 110°C, which is a lower temperature, would probably burn out again faster, or I can go up higher. So this is 130°C. It's only 17 degrees higher, or 13 degrees higher than the other one, so it's going to work. This one's got continuity, it's working, so let's put this one in. Let's try and do this as carefully as possible without wrecking any of these wires. My tweezers. This one here is I'm really concerned about. There's a little winding wire here, and we need to get this other chunk of wire removed. Pull on it. Just want to get it removed without breaking it. Here it comes. Coming. Okay, so we can pull that wire out. Now I can unwind this. Okay. Now the other side we'll use as our connection to the black wire. So leave that one alone. What we need to do I'd like to solder it on, but if we put the solder right next to the thermal fuse, the fuse will trip because it's going to get a lot hotter than 130°C if I hit it with an iron. So I'm just trying to think if I need to cut some of this wire off. Something like that. Gonna wrap those two together somehow. Give it a little bit of a mechanical bond. Now I'm going to use some heat sinking. Anybody remember these things? These are back in the days of germanium transistors. You used to use these on all the legs of the transistors as a heat sink. Put one here. I got two of them. Why not? I'll use them both. And I'll put another one on here just as a backup. Just to keep that wire cool. Clip these on and then I can solder this. And turn my iron down. I had it max. Let's turn it down. So you want to use as little heat as possible and get in and out quick. So let's see, I'll put my tip. And this should take right there. Good. Didn't even get warm. Now we're going to have to do some fancy fold over here. And we're going to have to connect the other side of the fuse to this end. Right there. Let's tuck in these wires first. Can you see this? Here, got a little fine wire here. It's pretty fine. We'll just wrap it and then we'll solder this. So hope we don't break this wire. That's the main thing. I don't want to have to go chasing into the core for the other end. Give it a couple of wraps. Now we need to heat sink it again. See if I can get one more on there. Solder this. Now we need okay, we got our resistance back. No, we don't. Black wire. Continuity all through there, so why don't we have anything here? Maybe my solder didn't take. Let's do it again. Yeah, I don't think the solder took. Let's hit it again with the soldering iron. All right, I think we got it that time. We got about 500 and some ohms, which is correct because this is center tap here, and then this. Okay, so we got our transformer back. So we got to wrap it up so it looks. What I want to do is fold this. Okay, it's its final resting spot. I'll see if I can get some tape in there, stuff some tape in there, just a little extra security. Okay, what I got is some of this stuff. This isn't very good tape though, it's not. Just want to get this, I'll just do it like this. Just want to get this covered with something. Just like that. Okay. That should hold it in place. And I'll put a wrap around here. Actually, I got smaller stuff that might be better. Pulled it off. That's no good. Let's just keep wrapping it. Okay. Put this side back on. I'm gonna get some new black tape here. Let's wrap this side as well, just because I took the tape off. Okay. that. Okay. So probably need a chunk about that long. Let's put this over here. There. Other side. Now we can wrap this up. I can't remember, did it go this way? This plate went on the bottom. Okay, we know that. Okay. There we go. Reinstall. Here's your part number. Okay, I'll clean this up and we'll put it back in. Continue on. All right, so after that little interruption, we got our transformer mounted back in. And let's check again for continuity on the plug. We should have somewhere around 500 ohms. Okay, we got nothing there. We turn on the power switch. $171 ohms. That sounds good. All right, so I think we're golden. Let's plug this in and give it power for the first time. If it's going to blow up, I think I'm going to throw my hands up in the air and give up on this thing. But I have high hopes. Let's try it. Okay, turning it on. Hey. It came on and then it shut off. What happened? Or no, there's two clicks. One click was the transformer. I could hear the transformer going on. Second click was the speakers. So what do we got here? We've got half a millivolt. Yeah, about half a millivolt on one channel. Appears to be working. Here we got 1.5 millivolts. So we'll tweak this one a little bit. Find my screwdriver. So the right channel, for the right channel, we need to tweak our VR101, which is down here. So I'm going to get this as close as I can to 0. It was already pretty close. Pretty good there. Now for the next test, leave power on for 5 minutes. Connect the DC millivoltmeter to test point 101 and 102 and adjust VR 104 for 5 to 6.5 millivolts reading on the meter. So I gotta get T101 and T102 are down here on the main board. So I make sure we don't have any heating. See, these get hot sitting at idle. This one's cold. These ones are warm. Okay, T101. T102. And we're a little high, so we need to adjust 104, which is down here between the two heat sinks, and turn this down to about 5. Yeah, I still need to let it warm up for 5 minutes. So I'll set it to 5 and I'll see if it creeps up. There we go. Actually, I think when amplifiers warm up, it creeps down. Okay, so I need to find this connection here, 103 and 104. Well, they don't make this very easy for us. Right in between a ground and a capacitor. Here's the other one. Okay. And we got about 9 here, so let's turn this down as well. Right about there. I'll let it idle for a while, and then I'll check it again. Now, this transformer repair I just did, one of two things is going to happen. Either it's going to work from now on, or it's going to short out again, and not short out, but overheat and go open again. Reason being, if it has any shorted turns, the transformer is going to heat internally, and it's going to use more heat than it can dissipate, so that's why the temperature rises and it pops the fuse. I'll just keep an eye on this. Good test for this would leave it on for about half an hour, and just come feel how hot it is. It shouldn't be hot to the touch. It should get a little bit warmer than ambient, but aside from that, everything should be good. So I'll let this sit for 10 minutes. I'll come back. I'll tweak the bias adjustment again one more time, and then we're ready to test. Alright, so we're wired in for a power test. Let's try it out. Plugged it in, turn it on, and we're set to auxiliary. We should have something here. We got nothing. What is going on? Why do we have no output? Oh, you know what? It'd help if I turned on my signal generator and outputted a signal. There we go. Auxiliary. Still plugged into auxiliary. We got nothing. We are outputting a signal. Alright, let's try it on disk. Disk. Nothing. Ah, you know what? I forgot to put my jumpers back in. Oh my god. Jumpers. Let's put these back. That would explain why we have a whole lot of nothing. Okay, so there's our signal. Kind of stops right there at 12 o'clock. The potentiometer has a hard time. Okay, so let's go times 10. You got a clean signal on both channels. Right up to clipping. Okay, let's get a reading on this. Let's see what kind of power output we have. Alright, so going up to clipping. And we have the soft clipping on right now, in case you're wondering. So I think right about there, we're going to call it, and it's 26.04 volts RMS. That's pretty good. Let's turn soft clipping off. Try one more time. Right there. 26.34. This is very, very slightly better. Balance pot, so it looks clean. Treble pot looks clean. Oh, hang on, I gotta turn the tones on. Tone defeat, okay. Bass pot, it's clean, everything's clean. You can see how this goes for a while. It heats up. You hear a little bit of whine from that transformer, not bad. Maybe if I hold the mic up you can hear it. Yeah, it's heating up pretty quick. I wouldn't want to run it too long on full power. I don't think the heat sinks are the greatest on this. Alright, so I think that was the result. Let's put it back together and finish this off. Okay, so we're done. 48 capacitors that were totally cooked, roasted beyond use, and they were in there, and but it's good now. It's working amplifier. lot of poor quality parts here. These are all supposed to be blue like this color, but look at how they all changed according to how they got roasted. Some of them are gray, some of them are pale gray, some of them are green almost. So a lot of heat damage here to all these caps. I did check the current consumption. When this is plugged in, turned on, it's consuming about 28 watts, which isn't overly high. It's probably a little higher than what I'd like it to see. I'd like to see around 20, 22 watts on idle. But 28 watts ain't bad, but I don't know what it is. Maybe it's poor ventilation, but it's got lots of ventilation. But if you have yourself a NAD amplifier and it's this vintage, I suggest you get it into a shop or somebody that can do it for you. Get the capacitors checked out because they're failing. It's a given. There's not much you can do about that. So yeah, so that's it for this one. I have the other one going to be coming up pretty soon. I'm going to do it separate because this video took too long as it was. There was a lot going on here and a lot of different stuff. We had to fix the repair on the transformer, and I suspect this capacitor, where is it? This one here, this little, no, that's not the one. Stay here. This one. This 1000 microfarad at 16 volts shorted out, and I believe that's what took out the transformer, the thermal fuse in the transformer. That's my thoughts anyway. So we're done. Anyways, thanks for watching, and we'll see you on the next one.